Hello students! In the previous video, we discussed trigonometric ratios and the unit circle. I asked you, what if I change this reference angle? Will the values of ratios also change if I increase or decrease this angle? To answer this question, it is yes. If we increase or decrease the reference angle, that is theta, the values of ratios will also increase or decrease. So if I retain our circle and look at it again, we can find answers to our questions. Okay, so let me now reduce this angle theta to 0 slowly and gradually. See what happens to sine theta. Recall that sine theta is this length of this side, that is between points A and P. So what you see is this length AB decreases gradually as we reduce theta. Watch it again. As we reduce the theta, the opposite side sin theta reduces to smaller and smaller size. Also notice that exact opposite happens to cos theta. Yes, as the angle reduces, the adjacent side cos theta increases. That is, the length of OB increases. Now what happens to tan theta? Evidently, it's not there, right? Yes, if you see carefully, this portion of the tangent, which is tan theta, is decreasing slowly as we decrease the angle, just like sin theta did. So when we reduce this theta to 0, this point A also moves but on circle, and this length reduces gradually. And finally, when the angle is 0, it is gone. So we don't find tan theta here. But, well, is it true? Not really. What we can say is the length decreases. What happens to the absolute values of this ratio, we are still to find it out. So let's note it down like this. When theta reduces, sine and tan also reduce, but cos increases. Okay, now let's increase the theta. See what happens to sine theta this time. Yes, it increases, while cos theta decreases. So as the angle increases, sine theta and tan theta increase, while cos theta decreases. Just the opposite of the previous case. Yes, while the reverse of it happens when theta decreases, sine and tan decrease and cos theta increases. In general, we can say that if an angle increases or decreases, so will the ratio. But what if we want to find the actual values of these ratios? Yes, I just said, what about the absolute values of these ratios at different angles? Let me tell you that we will limit ourselves to 5 specific angles, that is 0, 30, 45, 60 and 90. We will calculate the absolute values of 6 ratios that we have seen with respect to these 5 angles. So basically, we'll form a table that will look like this. Let us see what happens to trigonometric ratios if this angle theta is made smaller and smaller in the right triangle till it becomes 0. So let's take out the triangle from the circle like this. We just saw that as we decrease theta, sine theta decreases as well. So if theta is 0, then sine theta is also 0. What about cos theta? Yes, it increases. And in fact, just see here that it has become equal to the radius of this circle, that is 1. And tan theta? Tan theta also approaches 0. Therefore, we have sine theta 0, cos theta 1 and tan theta 0. Now this is from the circle where we understood the ratios. What about the triangle? So let's see this as angle ABO. This is theta. As it gets smaller and smaller, the length of side AB decreases. Simply speaking, the opposite side decreases. Yes, we know that if this angle is theta, then the side AB is the opposite side and OB is the adjacent side. and as usual AO is the hypotenuse. So we can say that as theta decreases, point A gets closer to the point B, and finally when theta becomes 0, AB also becomes 0 and OA becomes same as BO. In other words, points A and B coincide like this. So what we see, just this line OB, which is same as OA. Okay, so what is OB and OA then? Correct, it's 1 unit. So for now, this triangle AOB, we can say that AB is equal to 0, OA which is equal to OB which is equal to 1 unit. Mathematically, we can also say that drawing triangle is not possible when theta is equal to 0. Yes, here we can clearly see that it's just like a line and not a triangle. Okay, so now let's calculate the ratios for this triangle. We know that sine theta is equal to sine 0 here, as theta is 0. Therefore, sine 0 is equal to opposite upon hypotenuse, that is AB upon OA, which is 0 upon 1, which equals to 0. Similarly, cos 0, which is OB upon OA, which is equal to 1 upon 1, equal to 1. And tan theta is sine upon cos, or opposite upon adjacent, which is 0 upon 1, which equals 0. And yes, we said that tan theta does not exist when we reduce the theta. So let's put them in our table. Now what about other 3 remaining ratios? Let's find them out as well. Sec 0 is nothing but 1 upon cos 0, which is 1 upon 1 equals to 1. Cosec 0 is 1 upon sine 0, which is 1 upon 0 written as not defined. Cot 0 is nothing but 1 upon tan 0, which is 1 upon 0 again written as not defined. Now what if I change this theta and increase it to 90? Yes, what happens when we increase the angle? We will see that in our next video.